Welcome to Setting Course, an ABS podcast where we're charting the future of the marine and offshore industries. I'm your host, Brad Cox, and today we're on a boat. That's right, listeners. We're recording on board the tugboat Signet Capella, docked just off the Corpus Christi Bay in South Texas. The Signet Capella is the second commercial U.S. vessel designed, built, and verified using an end-to-end 3D design process. The first, the Capella's sister ship, the Signet Sirius, which is actually next to us right now. But I'm getting a little ahead of myself. We have some great guests on board to discuss the Signet Capella, the Sirius, and what 3D design can mean for the maritime industry. From Signet, we have Senior Vice President of Engineering, Tim McCallum. Thanks for letting us hang out on Signet's boat, Tim.
Thank you for coming.
And from Allan Ltd, we have Production Design Manager, Dmitry Kapiturov. Allan is a naval architecture firm in Vancouver, Canada, which developed the Capella's advanced rotor tug design in collaboration with Rotor Tug BV. Thanks for being here, Dmitry.
Hello, everyone. Thank you, Brad, and ABS team for organizing it. Really appreciate having me on board. And thank you, team, for hosting this podcast here on this boat.
And from ABS, we have Senior Engineer Scott Sienkiewicz, who was involved in reviewing the 3D design plans of the Sirius and the Capella for ABS. Welcome to the show, Scott.
Thanks, Brad. Great to be here. Thanks, Tim, for having us on the boat. It's a nice setting.
So let's go ahead and get started here. Tim, can you tell us a little bit about the boat we're on right now?
Absolutely. So this is the Signet Capella. She and her sister are the first 3D design vessels in the United States. She was built specifically to handle deep draft VLCCs escorting out of the port of Corpus Christi. She's a uniquely 3-thruster vessel. She has 2 thrusters in her bow, 1 in the stern, and she has extremely large winches fore and aft to handle the very large escort forces we expect in the safe transportation of these ships. She's a result of months of iterative design and simulation at Siemens Church in Houston, where we looked at what the application was to safely do this kind of operation, and then built a vessel that could meet that mission. And from there, we worked with Allan using computational fluid dynamics, marquee machinery, custom designing winches, and ABS, and making sure that everything met the rules and was safe in operation before we finally built the vessel. She had many ABS firsts in the U.S., Enviro notation on a tugboat, Cybersecurity 1 notation, low emissions vessel notation. We're all first for Signet as well. And she was the winner of the Workboat Boat of the Year 2023 with many other nominations for major boat awards.
And the Sirius and the Capella are, for all intents and purposes, nearly identical, right?
Yeah, they are sister vessels, identical in design, and serve the same purpose for escorting multiple vessels over the course of a day here in the port.
So, of course, we were talking about 3D design. It's not exactly new. I was using 3D design as a college student, a decade ago, but it's kind of starting to make inroads here in maritime. So, Dmitry, why is 3D design, really gaining ground, making waves now?
Well, yeah, Brad, you were exactly right. 3D design, not exactly new. And back to the late 90s, we started our exploration of 3D modeling with tools like Rhino or Ship Constructor. Rhino was particularly useful and still is for creating hull shapes in 3D and, surface models for finite element analysis or, computation fluid dynamics. On the other hand, Ship Constructor were used primarily for production design. And we would take class construct design drawings in 2D that was done in 2D and basically develop 3D model of entire vessel structure as well as system. And as an output of, the 3D model, we would develop assembly drawings, nesting drawings, piping spools, piping arrangements, etc., right? And having been exposed to 3D modeling since early on in my career, I always wondered, why? Why are we doing it twice? We're designing the boat in 2D, and then we're basically transferring it to a 3D environment. It looks like it's a redundancy, it seems like unnecessary. And couldn't we just jump in the 3D environment and design it right there? Also, we have to understand that I think it's a fundamental shift like when the engineering industry were switching from pencil drawings and drafting boards to CAD drawings and computer screens. With model-based design, 3D design, if you wish, all stakeholders such as, Robert Allan as a designer, Signet Maritime Corporation as a shipyard, and ABS as a client society, we have to be on board. So we have to all accept this and embrace this approach. And I think it's one of the important things that the younger generation of professionals, they're basically growing with 3D tools. And also, look at the video games. It's all 3D now. VR, it's so popular and getting more popular and popular right now. With all these 3D design tools, acceptance of this approach by all stakeholders, us as designers, operators, shipyard as a builders, and obviously new generation of ship designers, it looks like the shipbuilding industry, they're sort of ready to take on this shift.
And Scott, obviously from the class side of things, there's an interest there in that transition. What's been kind of your perspective and ABS's perspective on this kind of growing role of 3D in the industry?
Yeah, it unlocks quite a bit of potential from our side. Specifically, it creates a one source of truth, kind of to Dmitry's point about instead of having a set of 2D drawings and then maybe a production model in the shipyard or production drawings for the shipyard, you have everything within one model that everyone's working off of the same set of data and the same piece of information. And that's not just across owner, operator, designer, shipyard, and class. That's also within ABS itself. Multiple disciplines can work off of the same model because it has substantially more data in it than you might have in a 2D drawing. So it opens up that plus a lot of other potential down the road with further advancements in AR and VR, and gives us a lot of capability that we didn't have before with 2D drawings, and gives us a little bit more perspective in our design reviews that we may not have had with 2D drawings. In the case of this boat in particular, there were a lot of details, construction details that we would not have normally seen on a 2D drawing because the designer can't physically detail out every single aspect of the design in a 2D drawing. But in a 3D model, you get a better sense of how everything goes together throughout plan review. And it led to us catching a couple of things that we otherwise would not have in a 2D plan review type of review in the past.
And the fact that the designer, the engineer, the production manager, the fitter, the welder, the surveyor are all working from the same complete model in the shipyard, it eliminates some of the human error that comes with that 2D derivation that by very definition to what Scott's saying is imperfect. And it's great to see at our shipyard, we went from 2D production on the previous build to 3D production on this build. And we had 30-year production managers and supervisors working in a 3D model using the 3D modeling tools to do what they've done on paper for many, many years. So there was always a concern with us that there would be some resistance or some leftover reliance on 2D models that we couldn't get over. But very, very quickly, that team adapted to do production in 3D very effectively and see things that otherwise they wouldn't have seen and see things more natively in a 3D environment.
So Tim, how did you guys come about deciding to do this? Obviously, you've mentioned before that you were surprised that it was the first 3D, end-to-end tug. What got you guys to commit to it?
So yeah, we were approached by Robert Allan early in the design phase because we were already doing so many unique things on this vessel to approach ABS and Coast Guard with the ask to engage in the first 3D design in the United States. And frankly, we were surprised that we were the first. When you look at the scope of commercial shipbuilding in the United States, to say that it had never been done under class and Coast Guard approval before was exciting for us to pursue. And we had great buy-in from our leadership, our executive team, to take that technological leap forward and take a little bit of a risk in changing the way we did things in the shipyard and the way we communicated with Robert Allan and with class to accomplish the goals that we've done successfully in the past. And it paid off. We saw great dividends in the way that design was done and the way that we were able to implement it in construction.
From our perspective, from design perspective, we knew that we're going to be the first if it's happened. We want to be first. We want to be, leaders in the industry with bringing up. I was thinking, I jumped to Jamie. Hey, Jamie, I think it's a great opportunity to do it. Jamie McCarthy, he's our project director for this design. Let's do it. So let's engage Signet. Let's engage ABS and let's do it. So we contacted, like Tim was saying, we contacted them with Brad's idea. They're on board. They're like, yeah, let's do it. And then we called ABS team. We had a couple of meetings to go over the specifics and details, and they agree on that. And like, fantastic, we can do it now. And it was so excited, yeah.
So what are the benefits of the 3D design along that new build journey? Touching on design, plan review in class, and, actually building the boat.
From design perspective, I think we're, really increasing design confidence with the precision and accuracy that we're using with 3D design. And with 3D design process, we create highly accurate 3D model, even at the basic class design level. And this 3D model can see every single structural component of the vessel, along with the measure piping system. Out of this basic 3D class model, we can extract accurate weight, CG, and feed it to our stability team, for example. While the model is still not to the production level, We can extract accurate bill of material and provide it to our shipyard so they can start procuring the material. And obviously, a 3D model gives you the ability to use visualization, ability to identify potential clashes, equipment fitment, safety issues, etc., etc. And one of the most important things when we use this 3D model approach, I think it's a team collaboration. And it's not only within our design team, with our team members, it's with our clients. We invite our clients into the model early, significantly improving their feeling of engagement. As a result, decisions are made very quickly and very early in the design process. Again, we talked about it before, reducing redundancy of work. We're not replicating 2D drawings in 3D environment. We're designing for it in 3D, and I think it's really important. Optimization. With 3D model, we can benefit through design automatization. You can speed up certain process while doing 3D design. Not necessarily you can do it in 2D design environment. Improving designer experience. Designers, they are really enjoying working in 3D environment. They love it. And adopting new technologies such as augmented reality and virtual reality.
And, Scott, what about from the class perspective? I know you kind of touched on it already, but, what are the real benefits of 3D design in getting these, ships across the finish line?
Yeah, the biggest benefit, I think, of doing the plan review of the structure specifically in 3D is that you get a holistic picture of the structure of the vessel during the early stages of plan review. Typically with 2D drawings, depending on the designer, I mean, it varies widely, but you may get primary scantlings, but you may not get as much detailed design for foundations or other pieces of equipment in the early scantling package. You might get that stuff later on. Again, a lot of that depends on some other moving targets within production, but getting that holistic view of what the vessel scantlings look like, where the foundations are going to be, how things interact. When you get into seeing the deck house with the structure, it's not normal for you to, or for ABS to get structure drawings that include the entire hull scantlings plus the deck house. You tend to have some sort of breakup, whether it's by unit, zone, hull, deck house, wheelhouse. But in the case of some of these tugs we've done, you get a holistic view of the whole vessel in one model, which is certainly unique, and it certainly is helpful to get a better picture of what the boat is going to look like in the end, and for us to make a better evaluation of the scantlings in a more complete approach. Not saying that 2D drawings were not complete, but in 3D, you get to really see every scantling and every stiffener and where it actually is, which is super unique and incredibly helpful.
Yeah, there's no second guessing. If you're getting 3D model and you work with 3D model, you click the member, structural member, you get all the information, weight, CG, the length, scantling, everything. While in 2D, we cannot physically show everything, right? We cannot show every single component. So we kind of are limited to a certain degree. And not necessarily 3D approach takes longer for us. It will take pretty much the same amount of time. If you work in advance, if you look at your design, like making design decisions while in advance, planning ahead, really helpful, whether 2D or 3D, but also from the class perspective, they see everything, every single component of the structure.
And that helped us at length on equipment selection and installation in the shipyard when we were able to see an entire space in relation to where we were putting switchgear or a pump or a major piece of equipment. It gave us a much better understanding of clearances and then also the ancillary piping and equipment that had to go around it. We were able to visualize that in 3D as opposed to looking at drawing 17 in relation to drawing 14 and trying to interpolate the difference between the two. So we were able to build better utilized spaces on the vessel. And this vessel has an incredible amount of equipment in it for a 100-foot-long tugboat. And otherwise, I don't know that we would have taken as tight clearances seriously and knew we could do them as we did when we did in 3D.
Oh yeah, amount of equipment on these tugboats is enormous. We're getting more and more equipment and trying to feed it. And the boat, while they stay the same length, we're getting them more powerful. Every year, we're designing them more powerful and more powerful. So winches became bigger, equipment became bigger, etc., etc.
Even procedurally on install, when we looked at how are we going to install the thrusters from the underside of the vessel, how are we going to make sure where we rig them is appropriate, we had a much better understanding than looking at the underside of the deckhouse drawing in relation to the hull drawing. We could look at the whole thing in one shot. So the complete holistic 3D model gives us the ability to do that. We haven't had that before.
You're not looking at a drawing and not to belittle drawings, but you're not looking at a drawing and seeing a gray square that says, here be dragons, like you know exactly what's there and what fits.
Yeah. I mean, looking at a 2D on a flat piece of paper requires an imagination from the designer, the engineer, the welder, whoever it is, to better understand what it's supposed to look like when it's done. In this case, you natively see the 3D model and your brain says that's what the boat's supposed to look like, which sounds simplistic, but it makes a massive difference on the day-to-day workflow in the shipyard.
So you're kind of shifting gears a little bit to something a little looser and more fun. Of course, when we talk about 3D models, you guys kind of alluded to this already. I'm thinking computer graphics, gaming. We were up in the wheelhouse earlier. It felt like I was in the middle of a video game piloting a starship. So what else can these 3D models be used for? Like, is there potential for training purposes? Whether it be immersive virtual reality or augmented reality. What's the potential here?
Well, absolutely. Working in 3D environment allow us as the senior engineers to train and transfer our knowledge to young professionals much quicker. Right? It's much quicker and more efficiently. Can you spin 2D drawings in 2D? No, you cannot. But you sit down with a young engineer and you have your 3D model in front and you just spin it around. Hey, this is how the bracket should look like. This is a structural connection. It's so visual. You can show everything. You can show from different angle so they can understand what's the reasoning behind the thing, how you've done it. And I think it's very important. Another thing is ship repair. At any given time, you can extract the information about damaged or broken components. You have your 3D model, it's completed. So that's something that happened in the past that the shipyard would call us, hey, we damaged the part of the vessel. How we can get, like a steel parts quickly? Well, we do have a 3D model. It's all completed. So we just isolate these parts. We do quick nesting. We send it to the shipyard and they fix the boat.
It's actually a really good point about, down the line, like a shipyard that might be doing a repair is not going to have any of the nesting data that the builder did, but you have the hull geometry in the model and you can extract that easier. Yeah, that's a new thing that I don't think I've really thought about, but that's a great point.
And it's all the same. You know exactly what components you have to use as a shipyard. And it's also important, this collaboration between us designers and the shipyard. So sometimes it's designer will finish work, send the package and disappear. Now the shipyard, how are we going to extract the data? What are we going to do with that? So this relationship between the shipyard and the designer is really important as well.
Yeah, and that's a unique story that happened with this project. I mean, this project started in the middle of COVID, and we were meeting on Teams, and we were talking about how do we approach 3D design? How do we build a boat in the middle of the pandemic was a big question. The collaboration between Robert Allen ABS and Signet on better understanding the challenges we had with 3D design, better collaborating on not just getting a production package and building it, but providing feedback and iterating and having follow-up meetings on how to make the boat easier to build, how to make the boat more effective, was unique and something we hadn't done to that degree to this point. Dmitry, you hit on the training element. It's hard to teach people structure of boats off of 2D drawings. It's not intuitive, right? And when we start looking at the next generation of digitally native people, like we're hiring now, like we have become, it's much easier to tell someone that's a half-inch plate when they can look at the 3D model and see it's half an inch thick, and then read a markup and follow along on the drawing. So the training aspects of this, being able to show people what the boat looks like behind the curtain, is something that I don't think has really been fully addressed at scale.
And like you can look at the 3D plate and see that it's half an inch. Depending on designer, shipyard, the naming practice across drawings varies so widely. So, where plating callouts could be, sometimes they're in general notes, sometimes they're, over the plate themselves, sometimes they're below in a scale. But in a 3D model, like Dmitry said, you don't have to go and hunt on the drawing. I can't tell you the amount of time that I've spent looking for like a bracket thickness or a plate thickness or a stiffener call out, where it might just say on the stiffener DO or, some other moniker to point you to it's the same as this other stiffener. You don't need to do that. You can just click on it and the metadata is there. It tells you what the scantling is. So I think myself included and anyone in general, it makes things a lot easier. You don't have to kind of hunt for that information. And it might sound superfluous to someone that's never done it before, but I can tell you it can get frustrating having to look through a drawing just to find that a plate is a half an inch thick.
And with the build boards, how you can see what's behind this wall. What structure behind this wall? Well, if you have a 3D model, well, you can check it.
looking further out, obviously we could explore the training aspect, the other ways to use 3D models, but looking further out onto the future of design and engineering, there's a lot of discussion in the mainstream about artificial intelligence, generative design, stuff like that. But what could 3D design look like in 20, 30 years?
Well, let me start on this. I think with 2D design approach, we reach the ceiling. So we cannot really produce things in 2D any faster than we can right now. It's done. We plateau. On the other hand, with 3D design tools that we have, and also additional coding that we're doing in-house, we can find ways to speed up the process of the modeling. We're doing model much quicker because we can basically say, hey, and this is probably to you like AI things, we can identify rules how non-tight floors should look like. And we can say, okay, this is the rules. And you can say within the code, create me the floors at this location, non-tight floor within this location. So the software can recreate it for you very quickly, while a designer doing things in 2D need to draw every frame. And with this automation, the way we can optimize the designing the structure, we're not wasting time on that anymore. So the design spiral became much shorter. We can produce much quicker the design and send it to class. So we can do that, and then the shipyard can start building the boats much quicker. So this is the big benefit. I don't really think that AI and a generative design can take over everything completely, but certain components for sure.
I think this is what Dmitry's talking about here, and having tools that can assist in design. And I've been fortunate enough to be involved in some of the discussions with the Freedom team on this. I think this is a big reason why ABS went to a new system like Freedom for engineering plan review and engineering workflows. Is the first reason is we've taken an approach to be CAD agnostic so that we can really work with as many designers as possible in whatever CAD they're using. There are limitations, but trying to be as CAD agnostic as possible, knowing that going forward, it's not as simple as 2D drawings being DXFs or PDFs. Those were kind of universal, ubiquitous formats that everyone was using. That's not really the case in 3D. There's a myriad of different design tools that can be used, and Freedom helps us ingest those different types of models. And I know the Freedom team, this is long down the road, is working on, and they're aware of these generative type of tools that are going to come, working on things that we can use in 3D within Freedom to assist in our plan review and assist in getting plan review done more efficient. Obviously, long term, it takes a while. We just got over the hump with Freedom being launched, but I think we're already seeing the benefits with Freedom being out there and being able to use however many different types of CAD files we need to do what we need to do.
Yeah, I mean, this vessel was the product of a lot of iterative design already that was only possible in 3D. So we did initial live simulation with pilots in Tugmasters and the operation that it's performing every day to make sure we were building the right vessel for what we needed it to do. After that, we did structural elements that were iteratively simulated. The bow staple on the front of the boat is a massive structure that is responsible for transferring all of the force the tug can generate, both from its main propulsion and its escort capability, to a headline to a ship. We made minor changes to that over many, many, many tests that yielded metric tons of escort force that made the boat more capable of doing its job. Could that potentially be done in a generative fashion in the future as that technology develops? Absolutely. We could cut down that design spiral to build to the point where the iterative calculations are done automatically. And that's where it gets exciting. We're setting the groundwork here to have the base foundation to build all of these other technologies into as they develop using the same tools. The model will not change. The way we get to it very well may as that technology develops.
Yeah, so unfortunately, our time on the Signet Capella is wrapping up. So I wondered if each of you had some concluding thoughts you'd like to share with our listeners. Tim, why don't you go first?
To me, the bottom line of all of this is that 3D design brings a level of awareness to all the participants and yields a superior product and contributes to the overall safety of a waterway through technological advancement. We saw fringe benefits of this during the design process we didn't even expect that now we can carry forward on all of our future projects. At Signet Shipbuilding and Repair and Signet Maritime, we're honored to have been approached by Robert Allan and working with ABS on pioneering this big leap forward in the U.S. maritime industry. And it really does open pathways to future use of digital tech in maritime design that otherwise wouldn't be possible.
And Dmitry?
Well, I started pilot testing this approach and advocating for the model-based design a while ago. And I'm really excited that it's finally basically coming to fruition. Furthermore, I do believe that the relationship with Signet and ABS became even more stronger than we had before because we use this collaboration. We work with this 3D environment together. And we're making decisions as we go, as we design the boat. Involvement from the Signet Maritime was fantastic. We've got so much feedback from them in the early design stage. And I think we should continue on doing that. I think we should build on that.
And Scott?
3D really changes a lot for class. The biggest thing it changes for us is, like I said, giving basically almost a twin to the vessel in real life. From ABS's perspective, it gives using 3D a more of a collaborative environment, I think, between designer and builder. I think when people, especially the younger engineers we have coming, which we've talked about a whole ton here, is this newer generation of engineers growing up in this 3D and digitized world, they like interacting with the model. Not that we should, think it's a toy or enjoyable, but it's a tool that makes you want to collaborate with the designer and the builder more than you would have in the past. And giving you that holistic view of both the entire scaling package, how everything interacts is great. I mean, I'll touch on, I know we haven't done at ABS any approval of systems and equipment yet in 3D, but we have gotten some models from Robert Allan that show those things within the model. And even though there's 2D drawings for our machinery and systems guys, they have been able to utilize that model to better visualize some of the pipe routing and ducting and where machinery and equipment are. So I think when we get there, that'll be a huge step forward for everyone, including ABS, to do both structure and systems and equipment. Because we've seen the benefits, even though we're not doing the approvals yet, but we've seen the benefits of everyone working off of one source of truth, one model that shows the overview of the vessel. It gives us a better understanding of what it's supposed to look like rather than looking at flat sections on flat paper.
Yeah, so I really love that. And, we've talked about it a couple different times, talking about how it adapts to young engineers in a way in their learning styles and the things that they see and interact with every day. But we're wrapping up here. So, Tim, thanks again, to you and Signet for hosting us and letting us record an episode on a boat. I don't know that it's the first podcast on a tugboat. Probably not the first podcast on a tugboat. Almost certainly the first podcast on a end-to-end 3D designed tugboat. And, of course, massive thank yous to Dmitry and Robert Allan and Scott and ABS for traveling to join us for this episode.
Thank you.
Thank you.
Yeah, thank you for having me here.
And for our listeners out there, thank you for joining us on Setting Course and on board the Signet Capella. And if you like this episode, leave a review, share the episode, and follow us on your podcast platform's choice. Learn more about how the maritime industry is evolving. Visit us at www.eagle.org. Thank you for listening.